Okay, this is unit 6.6, definite properties of integrals and some more graphical integration. Consider the graph above. Interpret what this means. The integral from 0 to 4 of the function dx equals 7.5. So what this means is the area under the curve from 0 to 4 is 7.5. And so that is the interpretation of what this graph is, to use words. And so basically, this integral says that the area bounded by the graph of f of x and the x-axis from 0 to 4 is 7.5. So the area under this curve from 0 to 4 is 7.5. Starting out with these problems, example 1, the graph above is g of x. Find the following. So it wants you to find the graph of g of x from negative 1 to 4. So negative 1 to 4 is basically this area right here, which is the area of a triangle. So we're just going to use base times height divided by 2. The base in this case is going to be 5, and the height of the curve is going to be 3. And so the area here is 15 halves. Question 2. Find the area under the curve from negative 2 to 4 of the function g of x. So that is this area here. Again, that's another triangle. So we're going to call it base times height divided by 2. So the base here is going to be equal to 2. The height is going to be 3. So this is going to be 2 times 3 divided by 3, which equals 3 units. Next question, it says find the area under the curve from 2 to negative 10. 2 to 10 of the function. So basically we have this same rectangle here, plus we have this trapezoid we need to find. So from the previous problem, we already know that this is going to be 3, the area of the green part that we found in the previous problem. Plus we need to find the area of the blue shape, which is a trapezoid. And the area is going to be base 1 plus base 2 times your height divided by 2. So my base 1 is 3. My base 2 is going to be from 4 to 10, which is 6. And the height is going to be 2. So we have 3 plus 6, which is 9. And then the 2's cancel. And then 3 plus 9 gives us our final answer of 12. So these next examples are more of the same, just different shapes. So if we're going, like example 1 again, if we're going from 0 to 4, 0 to 4 is going to give us this trapezoid. The area of a trapezoid is base 1 plus base 2 times height divided by 2. And base 1 is going to be equal to 2. Base 2 is going to be equal to 4. My height of the trapezoid is 3. And all divided by 2. So this is going to give us 6 times 3, which is 18, divided by 2, which is 9. Next question, we're going from negative 2 to 6. So negative 2 all the way to 6 is going to give me this trapezoid here and this quarter circle here. So to find the area, we need to find the area of the trapezoid, highlighted in yellow, and the quarter circle, highlighted in orange. The area of a trapezoid is base 1 plus base 2 times the height divided by 2. And then the quarter circle is going to be pi r squared times a quarter. So in our example, our base 1 is going to be 2. Our base 2 is going to be 6, equal to 6. And then the height is going to be equal to 3. So this trapezoid is going to be 8 times 3 divided by 2, which equals 12. And then the radius of my circle is going to be 2. And then if I do this, I'm going to get 4, and then divided by 4, which cancels out. So this is just going to be pi. And so my final answer is going to be 12 plus pi. Again, the 12 comes from the trapezoid, pi comes from the quarter circle. Final example, we're going to go from 2 to 8 and find the area under the curve. So we're going to have the triangle plus the half circle to complete this area. So my triangle is going to be base times height divided by 2. So we have a height of 3 and a base of 2. And that just equals 3. Plus a half circle. My radius is going to be 2. And I guess it's more apparent to look at it straight up like this. So my radius is equal to 2. So this is going to be 1/2 times pi times the radius squared. And in this case, I'm going to get 4 times pi divided by 2. The 4 and the 2 are going to simplify to 2. And so there is my area, 3 plus 2 pi. Okay, final one of these examples. Same thing, graphical representation. Just recall that any area under the axes is negative. So this would be a negative area. And both of these are going to be positive areas. Okay, so it tells us that the function g of x is the integral from 1 to x of the function. Find the following values. So g of 2, if I plug in 2 into this equation, I got to plug it into here and find the area under the curve from 1 to 2. Because again, this x matches this x. Don't plug it in there. That's a t. So make sure that when you're plugging in for the variables that they match. And so basically for question 1 again, we're going from 1 to 2. So that is this little area here. So this is going to be base times height divided by 2. My base is 1 and my height is 1. So this is 1 times 1 divided by 2, which is 1/2. Question 2, we're going of g of 6. So if we're going from 1 to 6, we're going to take this area and subtract it from the area that is below the x-axis here in purple. Now, from question 1, we already have the 1/2 area. And again, I'm going to put from number 1, that one. And now we're going to subtract the other triangle that is from 2 to 6. And so my base of this purple triangle, and I guess let me highlight that in purple. So the base is going to be 4. The height is 2 divided by 2. And so this is going to be 1/2 minus 4. And 1/2 minus 4 is negative 3.5. Number 3, it says, let's find the value of 1. So this is going to be the area under the curve from 1 to 1. And so we want to find the area under that curve. That is a straight line with no base, so it is 0. And again, because you got to think of these, remember when we were doing rectangles, areas? Well, this rectangle's width is 1 minus 1, which is 0. So when you're doing the area, it's 0 times a height, which is 0. So there's no area under a straight line. Last one, so we're going to go g of 8 is equal to the integral from 1 to 8 of f of t dt. Okay, so we have kind of three shapes we're trying to find. We know this shape from question 2, so really all we need to add is this one here. Because again, we've already added these two together in this problem right here. This area was 1/2, and this area was -4. So I'm going to take -3.5, and again, I'm going to make sure that we say that that's from number 2, or question 2. And then we are going to add the quarter circle to it. A quarter circle is 1/4 pi r squared, and our radius here is 2. So this is going to be pi times 2 squared. Now this is 4 divided by 4, so we're just left with pi. So this is going to be -3.5 plus pi. Moving on to the second part of 6.6, we're going to start doing properties of integrals. Now the first property says that whenever you switch boundaries, if I reverse a and b, I can compensate by putting a negative outside. Now the reason why this works is this would be the antiderivative at b minus the antiderivative at a. Now let's say, for example, that the antiderivative at b is 5 and the antiderivative at a is 2. This is going to give me 3. But if I switch my boundaries around for this integral, this would give me the antiderivative at a, subtract the antiderivative at b. And again, remember, a was 2 and b was 5. And if I subtract those, I get -3. So notice that these are the same value but opposite. And so that's kind of why the property is true. And just a note down here, we always want the smaller number at the bottom of the what we call the integrand, which is just the integral. So we go from the smaller number on the bottom to the taller number up top. And so we always want to reverse that if it's the other way around. So let's try this problem. So for example, example 1a, if I want to find the integral from 1 to 5, just like we did in the first part, we're going to get these two areas. Now notice that we have two triangles. The first one is from 1 to 3. And if I do base times height divided by 2, in this case my base would be 2, my height is 2, and so this is going to be equal to 2. And the next one is this area, but this is a negative area because it's under the x-axis. So we're going to subtract the area from 3 to 5. And so this is going to be minus, again, base times height divided by 2. The base is 2, the height is 2. And so this is also equal to 2. And so we're going to get 2 minus 2, which in this case is 0. These are the same areas. They are just opposite signs. And a second way you can look at this is that you can add, but my height here would be -2. So if I switch this to a plus, and then I just make this negative, I'm going to get that this is going to be 2 times -2, which is -4, divided by 2 is -2. So we have 2 plus -2, which is also 0. Part B, I'm going to reverse the integral because, again, we want the lower boundary on the bottom and the upper boundary on top. So in this integral, we want the area from 2 to 3, which is the triangle in yellow. So again, my base here is going to be 5. My height is 2. So I have 5 times 2 divided by 2. And so we're going to get that this equals negative 5. And then part C, again, we have the same thing where we need to switch the integral. And now, if we're going from negative 2 to 9, we also have this additional area here in green and the one in blue. So to save some work, I already know that I have negative 5. And again, that's from question 1b. And then I'm going to subtract the area of the green triangle because it is below the axes. And my base there is going to be 4. My height is 2 over 2. And then finally, I'm going to add the area here because that is above the curve. My base is going to be 2. My height is 2. And so my final answer is going to be negative 5 minus 4 plus 2, which is just going to give me negative 3. Oh, but also, same thing I forgot, there's a negative outside. This negative that's here is going to go outside the function. This is going to be negative, and that's going to be negative. And so my final answer is actually plus 3. So again, using the graph, we're going to examine property 2. Examining property 2, so if you have a constant that's multiplied to the function, you can pull it out, just like you can do with derivatives. And so part A, we have a 3 outside, so we're going to pull it out. And we're going to find the area under the curve from 2 to 5. So looking at the first triangle, we have a base of 1 and a height of 1. And the second triangle, and again, this will be negative because it's underneath the curve. We have a height of 2 and a base of 2. So this is going to be 3. Don't forget the 3 out front, like I always do. And so if we complete this, we're going to get 1/2 minus 2, which is negative 1.5 times 3, which is going to be 4.5 as my area. Moving on to question B. We want to find the integral from 0 to negative 2 of negative 4 f of x. Now, there's 2 things going on. We do need to switch our boundaries. So that makes this negative from negative 2 to 0. And we are going to pull out negative 4 outside. So this is going to just be positive 4. And then now we need to find the base and the height of whatever shape is from negative 2 to 0. And that's that triangle that I highlighted there. Now, the base is easy to find. That's 2. Now, the height, notice that the height does not go exactly to 1. So we have to find the actual height. Now, to do this, if we know the equation of the line, we can plug in 0 to see what the height is. Okay, and so the slope of this line is going to be 2 over 3. And now to write the equation, we need to write it in point slope form. So pick your point. I'm going to pick this point. So that's 1 and 2. So this is going to be 1 and 2. And so to finalize the equation over to the left, there you go. There is the equation of the line. And again, we need to sub in x equals 0 into here, and that will find the height. So if we have 0 minus 1, that's negative 1 times 2/3. So that's negative 2/3. And then if I add 2 to each side, I'm going to get y equals 2 minus 2/3, which in this case is 4/3. So that is my height. That was a lot of work to find the height. But again, we're going to have 2 times 4/3. And so if you want to finish this, we can simplify this 2 and this 2. And so we're going to have 2 times 2 times 4, which is 16 over 3. And that is the area for part B. Part C, this negative is going to come outside. And again, we're going to switch our boundaries. So this is going to be negative, negative. The integral from negative 2 to 7 of the function. So negative 2 to 7 is going to be this triangle. Subtract the area of this triangle. So again, this area is going to be base of 5, height of 2. And this area is going to be a base of 4 and a height of 2. Base times height divided by 2. Subtract base times height divided by 2. And so we're going to get 5 minus 4. In this case, that is equal to 1. Last property. Sorry, second to last property. This one is a little weird. And I guess basically, if we have a function plus a constant, basically you can take whatever constant that is and times it by b minus a, and then to add the integral or the area under the curve of f of x. And I can show you with this example down here. So it does say that we know that from 1 to 4, the area is 4.5. So this area right here is going to be 4.5. Now let's look at a different equation. Let's look at the integral from 1 to 4 of f of x plus, I don't know, 3, let's say. This is a transformation. So basically, if I take all of these and move them up 3, I'm going to have this value. Move this value up 3. 1, 2, 3. So there's my new equation. Now, we know, again, that the area here is 4.5, just like it was down here. So we're basically taking all of this, and then we're moving it up 3 units. Now, if you ignore this bottom part, notice how I have another rectangle here. So when I moved it up 3, I added this area. Now, what is the area of this rectangle? This area is going to be 12 units. And so if I did kind of the property that it shows, this would be 3. Again, because we have our constant that's moved outside, our constant that's moved outside. And then we're going to take 4 minus 1. Oh, and I can't count, sorry. This is 3. And so notice, and then plus, you have your integral from 4 to 1 of f of x. So this new area is going to be 3 times 3, which is this rectangle, plus my original area, which was here. So basically, to sum it all up, when you add a constant, right, you still have your same area, but you have, when you move your function up, you have a square slash rectangle that can be determined by this value times this minus this. Because again, this would be the height, and the width is 4 minus 1. So that's kind of a reason why that works. All right, so we're going to use this area to kind of find all of these here. So applying the property, right, we have a constant. So we're going to move the constant outside and then multiply it by the boundaries 4 minus 1. So that is going to be 5 times 3, which is 15, plus my original area of f of x dx. And then we already know that that is 4.5. So this is going to be 19.5. That's my new area. Same thing applies here. We're going to subtract 1, multiply it by 4 minus 1. So this is going to give me negative 3 plus my original integral, which was 4.5. And so in this case, my new area is 1.5. Now, part C is trying to trick you. Look, we have a constant. We have to switch our boundaries. And we have our constant outside. So we're going to apply the previous two rules and the new ones. So let's do this one step at a time. Let's switch our boundaries first. But to not mess up, I'm just going to write the negative outside. I'm going to put a big bracket and do everything inside. So move the negative 3 out and then multiply it by the boundaries that are subtracted. And now be careful here because we do have a 2 that we need to pull out. So let's simplify this a little bit. We're going to get negative 9 for this part plus, and then again, I'm moving the 2 outside. Now, I know this region is 4.5, and then this is going to be 9 plus negative 9, which is going to equal 0. Last property, it basically says that if you have a number in between your boundaries, you can break up the integral into separate boundaries. So again, the integral from a to c is the same thing as the integral from a to b plus the integral from b to c. And it's really easy to visualize here. You're basically saying this whole integral that I'm going to highlight in yellow is the same thing as if I take this integral plus this integral from b to c, right? So the whole integral is basically the integral from a to b here plus the integral from b to c here, given that b is in between your boundaries. And so here we go. So we're given that we have an integral from 0 to 10. And we know that this integral right here is going to be 16. But we also know that from 4 to 10, so from down here from 4 to 10, that this integral is going to be negative 4. So I guess this is not a proper drawing. This should be below the x-axis. Like this should be maybe something like that where that's negative 4, but you get the idea. Right? And you can kind of see like, oh, from 0 to 4, that's our first question. This area plus this area has to equal 16. So this would have to be 20 minus 4 is 16. But let's see. So setting this up properly, you would say the integral from 0 to 10 of g of x is going to be equal to the integral from 0 to 4 of g of x plus the integral from 4 to 10. And because of space, everything here is supposed to have a dx like this one. I just didn't write it, but this would be a dx, this would be a dx. Now, we know this area here is going to be 16. And we know that this integral is negative 4. So if you just add 4 to each side, you're going to get that the integral is equal to 20. It's from 0 to 4 of g of x dx. So this is equal to 20. Now, part B, notice that part A gave us 0 to 4, and this is asking us from 4 to 0. So we're going to use this answer to answer part B. So if I flip my boundaries, this is going to be negative. And then I'm going to pull out my 3 outside. So this is going to be a negative 3. And this is from 0 to 4, g of x dx. Now, we know that this value is equal to 20 from part A. And so my integral is now negative 60. Okay, so now we're going to we have a constant. We know that we can pull out that that constant, sorry, and multiply it by the boundaries from 10 to 4. And then plus, do my integral from 4 to 10 of g of x dx. And we know this value is equal to negative 4. That's given here. And then completing this last one, this is going to be negative 5 times 6, which is negative 30, plus negative 4. So we have an area of negative 34.